In some cases, you'll want to use Wise's 3D positional system for sounds that don't have their position represented in the game engine. For example, in this project, based upon the Cube demo game, we have a sequence container that contains the sound of shotgun shells falling on the ground. We can imagine that when a shotgun shell is ejected from the gun, it falls to the right and bounces along the ground, potentially ending up several meters away. Unfortunately, the game doesn't provide any coordinates for where the shells are in the virtual world. So to create this sense of realism, we'll use Wise's 3D positioning in a user-defined mode. With the shotgun shells object selected, click the Positioning tab. Now, in the Position Source area, you'll see that the object is set to 3D game-defined positioning. For this to have any effect, positional coordinates for the shotgun shells would need to be sent from the game engine, and this is something that's not available in this case. In the Position Source area, click the User-Defined Radio button. Now, just below, we can see the Follow Listener Orientation checkbox already selected, meaning that the positions for the shells that we're about to configure are always relative to the direction that the listener, or in this case our player, is facing, which makes sense for our application. A little bit below, be sure that the Enable Spatialization checkbox is selected, as this is what allows for the sounds to be panned in a way that reflects the user-defined positions we'll be creating shortly. One last consideration is that the 3D user-defined positioning is based on the attenuation that is selected in the attenuations area. This object already has an attenuation share set assigned to it. For more information about attenuations, be sure to watch the attenuation tutorial. With our shotgun shells now set up for 3D user-defined positioning, we can now click the Edit button in the Position Source area. The Position Editor opens and displays something that resembles a surround sound panel layout, with the listener position being represented at its center. What we don't see is any form of control to position a sound in the sound field. This is because positional information is connected to something called a path, which is a user-defined trajectory for a sound object to follow. In the Paths area, click the New button. A control point appears in the display indicating where the sound will come from as it relates to the listener's position. Since shells are ejected from the right side of a gun, we'll move this position to the right. Since this shell will continue to move as it bounces on the ground, we can double-click to create more control points. Forming a path for the shell to follow. At the bottom of the Position Editor, there is a timeline, and every time we added a control point in the display, corresponding control points are also created in this timeline. This timeline indicates how long it takes for the virtual object in the game to follow the path. The sound of the shells bouncing only lasts for a few seconds, so we can adjust the timeline's length by clicking the Configure Timeline button. In this case, we'll set the value to 3 seconds. In the timeline, it's even possible to change the transition time between control points. Just deselect the Linear Mode checkbox and then move the control points on the timeline. In reality, the shells falling on the ground won't always follow the same physical path as they bounce along. So to further increase a sense of realism, we can randomize the position of the control points using the random range properties. The values that we enter here are actually a percentage value of the max distance property that's defined in the object's attenuation. Now, to create even more diversity, we can add more paths in the paths list. We'll start with the path we already have and just use standard copy and paste key commands to create new versions of this path. Once these are in place, we can go back and just make slight variations to the control points. All right, now, we also want in the play type area to choose the random option. This is going to set it up so that each time the shells are played, a new path is randomly chosen from our path list. And then finally, in the play mode area, choose the continuous option. This is so that as the shells bounce on the ground, we're ensuring that there's a constant motion to these shells. Now, as we play the shells sound, we can see and hear how we've got a lot of diversity in the position of the shells, even though the game itself isn't keeping track of where the shells are located in the game.